We have Chris here from Lit Protocol, who's going to be doing a workshop on easily add encryption and private data with Lit Protocol. Questions go into the Zoom chat and Chris will take them as they come in. So feel free to ask questions whenever. And with that being said, I'll hand the mic off to Chris.
Hey, how's it going, everybody? I am so excited to teach you all a little bit about Lit Protocol. It's very near and dear to my heart, as you can imagine. So very excited to get to share some of it with you, especially in the context of this hackathon, where I think there's some really cool stuff that you can build with it. So let's get started. What is Lit Protocol? Lit Protocol utilizes threshold cryptography to decentralize public key cryptography. So what does that actually mean? We all are familiar, hopefully, with public key cryptography and how it works and what you can do with it, right? You can sign things with a private key. That's like the basis of all cryptocurrency. And you can also encrypt things to the public key and decrypt them with the private key. And what we do at Lit Protocol is we use threshold encryption to decentralize that process. And so what that means is that there's a number of nodes in the network. Say you have 30 nodes, and you can set a threshold. You could say 20 of 30. And what those nodes do is a process called distributed key generation, where they generate a public-private key pair that nobody knows the private key to. The nodes each only have a share of that private key, and they can do everything that you can do with regular public key cryptography with that private key share. So they can sign with that share, and they can decrypt with that share. The user then can collect, say, 20 out of 30 decryption shares or 20 out of 30 signature shares, and then can create the signature or decrypt the content. And so that's how at Lit Protocol we decentralize access control. It's because there's a network of nodes that are running that are actually, they check conditions and then they use their private key share to do an operation for you. Okay. So I've talked a little bit about on-chain credentials. That's generally what Lit Protocol uses to check if you should be allowed to decrypt something or receive a signature for something. And what are on-chain credentials? Well, it's data that lives on-chain, generally as some state inside a smart contract. So it could be like, does a user hold an NFT? Are they in a DAO? Do they hold some amount of ETH? It could also be like, do they own a specific wallet address? And it could even be any smart contract call. So you can write a smart contract that does all kinds of crazy logic or pulls in all kinds of things from all over the chain, and then spits out a true or false, and you can use that as a condition for whether or not someone should be able to access something. So how does this actually work? The user is over here on the right, and on the left of this graph is a blockchain. And basically on the right, the user requests either a decryption, which is this key icon here, a key, or a signature, which is a signed JavaScript web token, also known as a JWT. And what the user does is they talk to every single node and they ask for a decryption share or a signature share. And with that request, they also send a signed wallet message signed by their private key. So what that does is it lets the nodes actually check, does this specific user meet this condition? And by checking the user's wallet signature, the nodes can also confirm that the person making the request is who they say they are and that they actually own that Ethereum address. And so each node, independently and in parallel, will check the condition on chain with an RPC call. So if the condition is like, does the user hold an NFT? Then each node will check like, with an RPC call, does this Ethereum address, is the balance of this Ethereum address of this NFT, is it greater than 0? And if the condition is met, then each node creates a decryption or signature share using its private key share. The user collects all of these above the threshold and is then able to decrypt or receive that JavaScript web token that they can send onto a server. So what can you do with it? There's basically two main things you can do with it, two like main paths of usage. One is for locking static content via encryption, and another one is authentication for dynamic content via the JWT. And so what that means, just to be clear, is that when you use the SDK, the Lit Protocol SDK, which by the way is a JavaScript SDK, it should work in the browser, it should work with React, it should work on Node.js on the back end, it should work everywhere. So that's how you'll actually interface with the network, is with the JavaScript SDK. And it can basically give you two things as output. It can give you an encryption key to decrypt something, or it can give you a JWT that's signed by the actual the network of nodes itself. So on the encryption side, on the encryption key side, there's a lot of cool stuff you can do. You can do things like encrypting and locking media files. You could do self-contained lockable HTML NFTs. You can do any kind of DWeb document encryption. So we have a ceramic integration that I'll go over in a little bit. And generally, like any private data that is not custodied by a third party is something that the encryption is a good candidate for. And then the final thing is what I like to call the Ready Player One like idea, which is if any of you guys have seen that movie, it's like a guy like locks up a bunch of money and then he dies. And then if anybody solves the puzzle, they can get all the money. And so that's like one thing you could totally design with this. You could have a smart contract that maybe somebody has to check in, like it's a dead man switch smart contract. Somebody has to check in. And if they don't, then the puzzle is unlocked and people can start trying to solve it. And so that's one of the cool things you can do with it. With respect to Lens protocol, I think there's a lot of cool stuff you could do with the encryption. You could have private publications where the actual content in the publication is private, and only people who meet a certain on-chain condition, maybe only everybody in you have to be in a mutual DAO with me in order to see my publications, for example, is one thing you could build with that. Just a sec, I'm going to pause here because I see some chat questions. I want to make sure that I'm getting them. Oh yeah, you encrypt dynamic content like streaming videos? So yes, for dynamic content, I think you would probably want to use the JWT, which is the other thing you can get from the protocol, right? So generally in our docs, we refer to the encryption use cases as static content and the authentication and JWT cases as dynamic content. And so with respect to streaming videos, we do have a Cloudflare integration you can use where you can upload your video to Cloudflare. Cloudflare Stream is the name of their product. And it will Cloudflare Stream will automatically transcode it into a bunch of different formats for you. And then automatically serve those formats up. And you can use our integration that we built with it to put any Lit protocol access control condition on it. So, the user has to own an NFT or whatever. And anyway, so we'll go over dynamic content real quick, and I'll come back to questions. For dynamic content, this is basically any content that's loaded from a server or content where you have a third party custodying the data. So Web2 experiences, we have a couple integrations with Google Drive, Zoom, and Shopify that we've built that you could play with, or you should build something on your own that's like similar. If you wanted to charge for a Web2 API, right? Like, you have to hold this NFT, or you have to, be actively paying me on one of the web or one of the payment streaming services, whatever the on-chain condition is, that you could absolutely use it for that. It's also great for content that receives frequent updates. So like if you had like a price analysis dashboard, and you were like, oh, like people who are members of my club that hold my club NFT can see my real-time price analysis, and it's like changing all the time. That's a really good use case of the JWT. Okay, and one question we have is, how large can the static content be? And can you set the unlock to be a timestamp or a block number? So the static content can be as large as you want. It is up to you to decide where to store it, right? So we only provide the encryption and decryption. You still need to like decide, do you want to store it on Ceramic or IPFS or Arweave or wherever. So that part is up to you. And with respect to the unlock being a timestamp or a block number, so that's not something that we support natively, but remember I said that you can use any smart contract function as your condition. So you could very easily write a smart contract that, the function says, if timestamp is greater than this, return true, else return false, and just use that smart contract function as your condition. And by the way, we support all the EVM chains pretty much, and we support most of the test nets as well. So if you wanted to like use a contract like this, but you didn't want to have to pay to deploy it on mainnet, you can totally, use it on any test net that you want. And so it could be free. The differences between lit and NuCypher. I'll come back to that one at the end, I think. But thanks for asking that question. That's a good one. Okay, so here's some of the things that we've built with lit, just to give you a bit of an example. So like Shopify, Zoom, Google Drive, Cloudflare Stream, GatherTown, and WordPress, those are all examples that use the JWT, right? Because they're all pretty much like Web2 services that use the JWT for authentication to these services. And then down here, you see IPFS encrypted files and the unlockable NFT minter. Both of those are use cases that use the static content, the encryption key use case. And let me actually show you some of these real quick here, just to give you a bit of a demo of how things actually work. It's like this is the IPFS encrypted files. And gotta put my MetaMask. And what this does is it lets you encrypt a file and basically specify the on-chain conditions for who should be allowed to decrypt it. And then the encrypted file gets uploaded to IPFS. So I'll just pick a random document here. And this is what I really wanted to show you guys is this modal here. So this is a component that we provide. I'll post a link to that in the presentation, and it's also linked in our docs, which I'll go over in a minute. But this is a component that we provide. You can use this within React or within any JavaScript environment, even just like a vanilla JavaScript environment. And this is a component that you can use to let your users decide who should be able to access something. So you could use this with Lens, for example, like the example I gave earlier of protected publications. You could use this for a user where a user could say like, only let the people in my DAO decrypt my publications, or only let like the users that hold so many various weird tokens, whatever this token is, only let users that hold more than one of these on Polygon be able to read and decrypt my my content. And just to sort of complete this demo for you, we'll say maybe somebody who holds more than 0.01 ETH can decrypt this. And like in the example of this application, like the user gets a URL here. And so you could share this with people that you want to share the content with. And then when a user, clicks download, if they meet all the conditions, it'll download perfectly. And if they don't, like this one doesn't have any ETH in it, I think. So this one should fail when I click download. And by the way, right here, you can see one requirement of using Lit protocol is that the user has a wallet and is able to sign messages with those wallets or with that wallet. So here's an example of that signing process. And so, yeah, you can see right here, it says unable to download because I don't meet either of these conditions, right? Because I switched to a wallet that doesn't have this amount of ETH. Okay, so one other thing that we built that was kind of fun was being able to control a Tesla with an NFT. And so that code is all open source, if that's interesting. The way that it works, just to see, so, to give you an idea of like the kind of things you can build in the architectures, is that a user, like a Tesla owner, mints an NFT, and then they auth with Tesla and get like a token for use to talk to Tesla. They encrypt that token once with a symmetric key, and then they encrypt it again with Lit. And then the symmetric key lives on like a serverless function. We use a Cloudflare worker for this. And so when a user shows up and wants to like drive the car and they have the NFT, they first decrypt that OAuth token with Lit, but it's not fully decrypted. It's still encrypted with a symmetric key that lives on the server. They send that up to the server. The server validates, again, that they meet the conditions. And then the server decrypts the credentials, then talks to the Tesla API on behalf of the user. And so like what's cool about that is that like the credentials only exist in their decrypted form like when they're being used for something. They're not just like laying around where somebody could just show up and steal the credentials. Okay, features. Yeah, so let's talk about some of the different things you can do with Lit in terms of like some of the more advanced features. Obviously, we talked a lot about provisioning an encryption key or a JWT. We also support Boolean logic, which is like and or conditions. So you can combine multiple things, like the user has to be in a DAO and own this NFT and have like more than 2 ETH or whatever. And you can use those across EVM chains. So you could say like, this user has to own a CryptoPunk on ETH and be in a DAO on Polygon, and that's the only way that they can access this content. We also support updatable or permanent conditions. By default, when you use the SDK, conditions are marked as permanent, but there's a flag you can set permanent false, and then that will let you update them in the future, which will let you do things like, for example, if you want to revoke permissions from someone, you could use an updatable condition to do that. We have multi-chain support. As I mentioned, we support almost all the EVM chains. And we also support Solana and the Solana testnets. It's free right now. And also, full disclosure, like we are building on a decentralized architecture, but right now we are running all of the nodes as we progressively decentralize. So I know this is like a hackathon, so people hopefully won't store anything valuable anyway, but like right now I would avoid like, storing anything high value in Lit until we can decentralize the infrastructure some more, which is we're in the process of doing that right now. And we think we'll have a more decentralized network up within the next few months. And we, like I said earlier, we don't store anything for you. It's up to you to bring your own storage solution, then you can encrypt your stuff with lit, store it wherever you want, and then nobody can read it without meeting the conditions, even though you stored it in a public place. Like IPFS is and Ceramic and Tableland are all public. So this is the access control modal that I showed you guys earlier. And we have some docs on this here with some different ways to utilize it. We have some example code where you can see where it was used. Definitely check out the docs. Those are available at developer.litprotocol.com. And this is where you can find like basically everything you need about how to use lit. Oh, right. Okay. The ceramic integration. Yeah. So that's a good one. Some of you guys will definitely want to use this. If you're using ceramic and you would like to have private data on your hackathon project, you can use lit plus ceramic to do that, which basically means you're using you're using ceramic for controlling write access, and you're using lit for controlling read access, because the data is encrypted with lit, and only the people that are able to decrypt it are able to actually read that data. And so we have a NPM package that basically just like glues lit and ceramic together. That might save you a little bit of time if you're planning to use these two things together. And we also have an example implementation that utilizes that package as well. So if you're going to use ceramic and you want to have some private data, this is probably like a good package for you. And yeah, we have a ton of example code. So hopefully that'll help you get started and get going a little quicker. Everything from like just examples of how to use the SDK up here to some things like here's how to use like Cloudflare to protect any URL on the web. So if you like want to protect a URL that you don't have access to or a way to gate, because you can't control that server, you could put this in front of it. The downside to using something like this is that like once the user, like an authorized user, has visited the page, then they like have the URL and they can just give it to other people. So this is like not an ideal way to protect content. Like what's better if you're gonna protect something on a server, is to use like this example right here. Yeah, this is a example to gate dynamic content on a server. And this, what's better about this is that if you like meet the conditions and you go to the server and you get the page, right? You can always take a screenshot, of course, or like print a PDF or whatever. But if you take that URL and send it to somebody else, it won't work for them, because every request requires that the user present a JWT from lit, which proves that they meet the conditions, and the user that you share that with won't have that. Like I mentioned earlier, we have a Cloudflare integration for streaming token gated videos from Cloudflare. The ceramic integration that I discussed here. We have the modal, the share modal that I just discussed, and I think that's pretty much everything that I wanted to get through with respect to the documentation and things like that. And I'd love to talk a little bit about the differences between lit and NuCypher. And then if anybody has any other questions, or like if you had a question that you didn't want to write in the chat and you wanted to ask verbally because it was like really long or something, then you can pipe up and ask that in just a sec. And so the differences between lit and NuCypher. So NuCypher uses proxy re-encryption, and lit doesn't. Lit uses threshold cryptography. And the main difference is like with proxy re-encryption, like another person generally has to show up, or not another person. The original person that owns the content has to show up to grant access to every new person, right? And so the example that we gave earlier of like Ready Player One and building that with lit protocol, you can't build that with NuCypher, right? Because like you're dead. You can't show back up and grant proxy re-encryption access to like the person who solved the puzzle. And that's like one of the like use cases where lit protocol really shines is in locking content up behind an NFT, right? Because you can put that NFT up for sale and you can like go about your merry way, your life. When somebody buys that NFT from you, you don't have to show back up and give them access to that data by re-encrypting it to their public key. Instead, like you just like live your life. You never have to show back up. That person is just able to decrypt it by default. And when they sell it to another person, that person is able to decrypt it in perpetuity. It's the same thing for like when you think about is a user a member of a DAO, right? It's like the set of users that's in a DAO is constantly changing. It's like people are coming and going, they're joining and leaving. And so if you had to grant access like manually to every new user that joined a DAO, and then revoke access from every user that left, it would just be like a huge pain. And so instead, what we do is we just like check the blockchain when you want to access it to see if you meet the condition, and then selectively, you know, do the operation of decrypting or signing only if you meet that condition. Okay, somebody asked, how does lit compare to unlock protocol and Mintgate? Lit is like a developer tool, basically. Like we provide an SDK. Unlock and Mintgate are primarily like consumer tools. So like they give you like a dashboard, they give you, you know, everything you like, it's all like point and click, basically. We're like really focused on building out the SDK. Also, like lit is actually decentralized. I mean, like it's not because we're running all the nodes, but it will be. Versus like unlock protocol and Mintgate aren't decentralized. They hold on to the content centrally and selectively release it. And what that means is that like if you're like an engineer at Mintgate or unlock protocol or something like that, you could just like go in the database and like steal all the locked content. There's nothing like stopping you, right? Versus like with lit, it's like it's encrypted, right? It's mathematically secured. So it doesn't matter like what privileges you have at lit protocol. Like we here at the company can't see your content and never will. And then yeah, we've built a bunch of consumer apps. Like you can see some of them here. And so that's like one area of overlap, I would say, between unlock protocol and Mintgate. But this definitely isn't our main focus versus I think it is theirs. Cool. I have about 1 minute and 30 seconds left, I think. Does anybody have any other questions, comments, anything at all?
Hey, Chris, you actually got a question in the Discord chat. Fernando asked, can you elaborate on Cloudflare related topic just mentioned?
Sure. Yeah. We have a couple different things for Cloudflare. We have Cloudflare Stream integration, which like this essentially lets you embed videos and live streams that are token gated. In order to use this, you'll have to have a Cloudflare account and a GitHub account, and this little widget thingy here will let you deploy everything to your Cloudflare account to make this like super easy to use. And then you end up with like a UI where you can like, you know, upload your videos, set your conditions, like it's all very smooth. The other thing we have for Cloudflare is an example of protecting any URL with a Cloudflare worker. And this, like, you don't have to use Cloudflare for this. You could use any serverless worker for this. But Cloudflare is just like a pretty easy one to use. So if you wanted to like verify a lit JWT inside of a Cloudflare worker, this would be the example project that you would want to take a look at.
Awesome. So it looks like that's all the questions that we have for now. If you have any more questions, feel free to drop them into the sponsor Lit Protocol Discord chat, where I'm sure the team will be more than happy to answer. And with that being said, Chris, thank you so much for taking the time to do this awesome workshop with the LFGrow hackers. I can't wait to see what everyone makes during judging next week. And with yeah, I hope everyone has a great rest of your day or evening, morning, wherever you are.
Yeah, thanks so much for having me. Appreciate it.
Of course. All right. Bye, everyone.